The event, application, and practical experience requires students to apply their theoretical knowledge using physical or digital tools, such as virtual simulations, in general or specific environments, for example, the laboratory. The practical experience allows students to recall their theoretical knowledge and apply it. This helps the student to test new perspectives and develop new skills. To do this, the teacher can propose analyzing case studies, carrying out exercises or experiments, or creating prototypes. All these activities, useful for gaining practical experience, can be conducted in physical spaces, in the classroom, in the laboratory, through field visits, or using digital tools, such as specific software or virtual simulations. In the traditional approach, practical experience usually takes place only after a phase of low interactivity content collection. It is the teacher who introduces the topic, presenting the general principles that will later be observed during the practical experience. In doing so, the student is left to independently reflect on the process carried out. However, students are not always able to independently activate reflective and metacognitive processes. For this reason, it might be useful to try reversing the scenario and fully valuing the practical experience and the metacognitive processes that follow from it. Let's turn to the Kolb cycle for help, one of the most well-known pedagogical frameworks that supports experiential learning. This involves 4 phases. The first, concrete experience, captures the student's interest. The second, reflective observation, helps to understand the experience just had and encourages students to reflect and think critically. The third, abstract conceptualization, which addresses the need to generalize and understand processes, systems, and broader contexts beyond the individual experience. And finally, the fourth, active experimentation, where the consolidation of acquired skills is facilitated and students prepare to experiment and learn again. On our board, we will therefore first insert the concrete experience, which corresponds to the first phase of Kolb's cycle. Then we will add the reflection, accompanied by the collection of low interactivity content. Here we follow the second and third phases of the cycle. The teacher provides some prompts to the students and guides them in their reflection. We then conclude with the fourth phase of Kolb's cycle. Here, the teacher could propose a brief production and research activity through which students can consolidate and experiment with the knowledge they have acquired. This final activity could also be moved to an asynchronous online format, for example, by offering students guided exercises that help them validate and personally experiment with the knowledge acquired in class. Proposing a particularly stimulating or innovative practical experience, such as a field activity or a virtual reality experience, often drains a lot of the teacher's energy, who may risk not devoting equal attention to other elements of the learning path. So let's conclude with a list of key steps that teachers should not overlook when designing a practical experience. Clearly define the roles of all the actors involved, what the teacher does, what the tutors do, and how the students participate, whether individually, in pairs, or in groups. Properly organize the sequence of activities to be carried out without forgetting to also define what happens before the experience, such as asking students to review some preparatory materials and what happens afterward. For example, how to conduct the reflection phase, what prompts and questions to propose, and so on. Prepare all supporting materials for the activity in advance, such as instructions or checklists useful for carrying out the experience, or small exercises or prompts to provide to students to help them with reflection. Properly organize the physical spaces where the experience will take place. Simply put, if we're in a classroom, we might decide to arrange tables and chairs in a circle, or if we're in a lab, it's necessary to ensure that all workstations are equipped with the required equipment. Finally, in the case of virtual simulations, prepare not only the software environment, but also the necessary digital tools. Often these experiences, especially when dealing with large numbers of students, require careful preparation.